Hi fellas, this is Schematics again to the solution. Welcome back to another video tutorial. Well fellas, today we're gonna solve uh, a problem related to mass spectrometer. Okay, so let's get started. So let's read the question at first. A mass spectrometer can be used to measure relative isotopic masses. So the first question they have asked is state the meaning of the term isotopes. So what do we mean by isotopes? Okay, so the total mark for this question is 1. So let's write the definition. So isotopes are the atoms of the same element isotopes are the atoms of the same element with same proton number or atomic number, as you can say, same proton number or atomic number but different mass number. Okay, well, that's the definition of isotope. So the isotopes are the atoms of the same element with the same proton number but different mass number. So the main thing of these definitions are this: the same atom, the same element, then same proton, then different mass number. We need to mention this thing in the definition. Okay, then we are able to achieve this mark. Okay. So that was easy. So now fellas, now let us move on to the next question. So in the next question it has asked, in a mass spectrometer a sample of the vapor of an element is ionized. State how this ionization is carried out. So in a mass spectrometer a sample of the vapor of an element is ionized. State how this ionization is carried out. So if we look at the question carefully, then we are able to see that here they have asked us about the process. Okay, so in here they have asked us about the process, so we're gonna discuss about the process. Okay, so here the vapor of the element is bombarded with high energy electrons, so the answer would be like this: vapor of vapor of sample, okay, is bombarded. We need to mention the word bombarded over here. Is bombarded with high energy electron. Okay, so the vapor of the sample is bombarded with high energy electrons, okay, to knock one or more electrons. So here the main thing is happening over here is vapor sample is bombarded with high energy electrons which knock one or more electrons from the outer shell. So we don't need to mention about this piece of information that knocks one or more electrons from the outer shell. So we just need to mention about this thing since they are asking us to uh, discuss about the process, how it is ionized. Okay, so here we will say that that vapor of sample is bombarded with high energy electrons. That's it. Okay, so if we mention about this word bombard and high energy electrons, then we are able to achieve this mark. Okay, so this is actually what is happening here. Okay, so this is what actually happening here. So that's the answer to this question. Okay, well fellas, there is one thing that we need to know, that we need to avoid giving reference to ionizing or forming positive ions. Okay, just as before we have discussed that we should not mention about knock one or more electrons from the outer shell. That is that piece of information is irrelevant here, since they are asking about the process of ionization here. So we will concentrate on this part. Okay, so here we will only discuss, we will be concerned about this part. Okay, so we will discuss about this part, that vapor of sample is bombarded with high energy electrons. That's it. We don't need to mention earlier, since we need to mention further, since we don't need to mention further any further. That's because the total mark for this question is 1. So here we will just say this thing, and we don't need to discuss about ionizing, forming positive ions. Okay, or if you just write the equation, the ionization in equation, you won't gain any mark for this question, since they have asked us about the process. Okay, so that is why this should be the answer. Okay, so I'm telling this thing once again, that we should avoid giving reference to ionizing or forming positive ions. Okay, so we will not discuss that how we will not discuss that ionizing, forming positive ions is being happening here. Okay, happens here, ionizing happens here, or forming positive ions happens here. Okay, or or just mentioning about the equation. Okay, we need to avoid these two things. We don't want to, okay, we don't need to give reference to ionizing or forming positive ions. This is one thing that we need to know, that we need to keep in mind. And another thing is that we don't need to mention the ionic equation, since in the next question we are asked to give the ionic equation for this step. So fellas, this is the question, this is the actual this is the actual answer to this question. So I hope that you have get it clear. So now let us move on to the next question. So if you have any confusion or question regarding this answer, please let me know in the comment section. Okay, so now let us move on to the next question. Complete the equation showing the simplest ionization of a vaporous element M. So here they have asked us to write the ionic equation for the simplest ionization of a vaporous sample M. So what is happening here? Here at first we need to look at what is happening here. So here an electron and a high energy electron is given to this element, gaseous sample. Okay, so a high energy electron is being given to this gaseous sample over here. So this gaseous sample would knock, oh well, sorry fellas, this is not magnesium, this is sample M. Okay, I thought that it was magnesium, sorry. This is for gas. Okay, so this is for the state of this sample. Okay, so this is element M, and this is in gaseous state. It means that it is in gaseous state. Okay fellas, by the way, so here this particular element is given high energy electron. So this high energy electron will knock one electron from this particular element. So this is how ionization occurs. So here we will be left with M plus ion, gaseous ion, M plus gaseous ion with 2 electrons. Okay, so how we are ended up here with 2 electrons? Well, before there was one high energy electron, and now it has knocked another 1 electron. So this summed up with 2 electrons. Okay, so this is how it works. So this is the actual equation for this question. So fellas, I hope that you have understood this equation. So in here, a high energy electron is given to this element, okay, knocking another electron from this metal, sorry, from this element, knocking another electron from this element. So here, leaving this element with positive ion, leaving this as positive ion and 2 electrons. So this is how we're gonna write the equation. So fellas, now let us move on to the next question. How the ions are accelerated in the mass spectrometer? Well fellas, uh, here we need to just mention about the step where the ions are accelerated in the mass spectrometer. Here, if we just write the answer electric field, then we are able to get this mark over here. So here, the ions are accelerated in the electric field. Okay, the ions are accelerated in the electric field. So there are few steps that the ions goes through. Ions at first goes to the velocity selector to have uniform, well, no, at first ions goes through the electric field to be accelerated. The ions are accelerated to the electric field, then it goes to the velocity selector where the ions will have the uniform velocity, then it passes through the magnetic field. Well, since there is three section, one section is electric field and another section is velocity selector and another section is magnetic field. Okay, so since electric field and magnetic fields are two different things, so we can't say electromagnetic field. So some of the students get confused with this part, such as they write the answer in this way. They mention about they always try to mention about electromagnetic field in over here. That's totally wrong. Okay, so actually the ions are accelerated in the electric field. Okay, there is one point, this is one point. Here the ions are accelerated in the electric field. Okay, and there is another point, ions are accelerated in electric field, then ions are deflected in the magnetic field. As we can see here, that here there are two parts separately. One part is one part of the mass spectrometer is electric field. Another part of the mass spectrometer is what we call magnetic field. Okay, so they are totally different. So in the electric field, the ions are accelerated. Okay, and in the magnetic field, the ions are deflected according to their mass by charge ratio. Okay, according to mass by charge ratio, according to ions mass by charge ratio. Okay, so the ions are here, the magnetic field, here the ions are deflected in the magnetic field according to ions mass by charge ratio. So at first the ions are passed to the electric field where the ions are accelerated, then the ions are passed through the velocity selector where the velocity of the ions kept constant. Okay, to have constant velocity, the ions are passed to the velocity selector, then the ions are passed Then the ions are passed through the magnetic field where the ions are deflected according to mass by charge ratio. Okay, so that's the answer to this question. Okay, so that's it. So this is how we're gonna answer this question. So once again I'm repeating this thing once again, that don't write the thing, there is no thing such as, there is no thing such as electromagnetic field. Okay, there is no thing such as electromagnetic field in the mass spectrometer. So electric field and magnetic field exist separately in the mass spectrometer. Okay, so that is how it goes. So fellas, I hope that you have understood this concept. Okay, here we have discussed about the differences between electric field and magnetic field. Well, there is also a velocity selector in this step. We didn't discuss in details about that since it is not relevant to this question. Well, later on, if there is any question regarding to the velocity selector, if we find any question regarding to the velocity related to the velocity selector, then we're gonna discuss. Okay, so we are just leaving that on now. So now let us move on to the next question. I hope that you have understood the concept behind the previous question. Okay, now let us move on to the next question. Ions with the same charge and traveling with the same velocity are then passed through a magnetic field. Okay, so the ions have the same charge, same velocity. Okay, these are the 2 points. The first point is ions have same ions have same charge. The second point is ions have different velocity. Okay, so passed through a magnetic field. So now it has passed through the magnetic field. So before we have learned that ions are deflected in the magnetic field. What happens to the magnetic field? What happens in the magnetic field? The ions are deflected in the magnetic field according to ions mass by charge ratio. Okay, so here let's see how. So in this question it has asked, let us see, the path of one ion is shown. Add a line to the diagram to show the path of a lighter ion as it passes through the magnetic field and travels to the detector. So they have asked about to draw the path of a lighter ion as it passes through the magnetic field and travels to the detector. Well, the expected path should be this. Well, it is looking like straight line. It shouldn't be the straight line. Okay. It should be a curved line. It's not smooth enough. Well, now it's looking cool. I hope that. So now this is the path for lighter ions. Okay, lighter ions, and this is the path for heavier ions. So this is the path for heavier ions, and this is the path for lighter ions. Okay. Now let's differentiate why this path should be for lighter ions and why this path should be for heavier ions. Okay. So here let's see why. So in here lighter ions, as we all know that lighter ions have less mass. Okay, but same charge and velocity. Okay, same charge and velocity. So it will deflect more. Okay, so here Since lighter ion has less mass but same charge as well as same velocity, so it will deflect more in the magnetic field. Okay, so in the magnetic field. So for heavier ions, if we see heavier ions will have more mass, but uh, dif more mass but same charge and velocity, so it will deflect less. Okay, but same charge, and velocity. Okay, so it will deflect more, less, not more, less in the magnetic field. So this is how it goes. Okay, okay. So now let us summarize this thing up over here. So lighter ions have less mass but same charge and velocity, so it will deflect more in the electric field, in the magnetic field, Well, let me repeat this thing once again. Lighter ions have less mass but same charge and velocity, so it will deflect more in the magnetic field. Okay, but in the case of heavier ions have more mass but same charge and velocity, just like lighter ions, so it will deflect less in the magnetic field. Okay, so heavier ions have more mass, so it will deflect less, and lighter ions have less mass. Since lighter ions have less mass, so it will deflect more. Okay, so that is how it goes. uh, well fellas, that's the answer to this question. So that is why the path should be this, not this. Okay, so the lighter ions will deflect more than the heavier ions, since lighter ions have less mass than the heavier ions. Okay, so that is how it should go. So fellas, I hope that you have understood this question as well as the solution. So now we have came to the end to this solution. Okay, so that's the end of this solution. So in the next uh, tutorial, we're gonna solve the next question to this series. Okay, in the next episode, we're gonna solve the next question. So until then, stay tuned, stay awesome, stay cool, best of luck for your exam, and as always, peace with chemistry.